Alright, so here we are with the 6-5 Multiplying Polynomials notes for intermediate algebra. So we are talking about multiplying polynomials, and so we just need to make sure that we remember when you are multiplying powers with the same base, meaning that variable is the same, so looking here, x and x, keep the base and add the exponents. So we keep the base the same, and then we add the exponents. And so that means that we're going to end up with x to the 2 plus 3, and then that means that it's x to the 5. So we never actually change that base, so notice it's always x, and then as much as it says multiplying here, you're actually adding the exponents. So we do need to be sure that that happens. So this first one here, again with the parentheses, it's not really helpful unless we have a negative, and so really it's just 6 times y cubed times 3 times y to the 5th. And so technically we will just be multiplying the 6 and the 3, so 6 times 3, which will be 18. And then we'll be multiplying the y cubed and y to the 5th, and that makes y to the 8th. So that is multiplying monomials. Remember that that means that there is one term. Other than multiplying monomials, sometimes we will also be distributing, and in this case we're distributing just a 4, but it could be 4x, it could be a 4x squared, and remember distributing is multiplying, so we're doing 4 times 3x squared plus 4 times 4x minus 4 times 8. So everything has that 4 being multiplied into it. And so 3 times 4 makes 12x squared plus 16x minus 32. So anytime that you are multiplying by just a number, every variable just kind of tags along for the ride. Alright, then we have what we call the area model, or the box. And so we may have kind of jumped into this a little bit earlier, but the idea is that you have a binomial, so we're going to have 2 boxes, and another binomial, so another 2 boxes, and they're going to multiply kind of like a Punnett square, if you've seen that. But the idea is that x plus 3 is going to go along the top, and then the x plus 2 can go along the side. It doesn't matter which one is which, so you could switch those around if you felt like it, but the idea is one is on top, one is on the left side, and now we go through and multiply it out. So x times x makes this box x squared. Then x times 3 makes this box 3x. Then x times 2 makes the next box 2x. And then 2 times 3 makes the last box 6. With these, what happens is generally you will be able to combine the 2 middle terms. And so officially, we have x squared plus 3x plus 2x plus 6. But of course, we know that we can combine 3x and 2x. And so we actually have x squared plus 6x plus 6. And that is your result. Just expanding that. Alright, so we're going to do it for this one. So again, we're just multiplying, which means that I have a 2 binomial and a binomial here. So I'm going to need a 2 by 2 box. Along the top, I'll have s plus 4. And along the side, I'll have s minus 2. And then you go through and multiply them out. So s times s makes s squared. S times 4 makes 4s. Negative 2 times s makes negative 2s. And negative 2 times 4 makes negative 8. Again, these 2 pieces are going to come together, and so we end up with s squared plus 2s minus 8. Alright, next one, we've got x minus 4 squared. So x minus 4 squared really just means x minus 4 times x minus 4. There are people that will try to do this square being distributed, but this does not equal x squared minus 16. So just be very careful that that does not happen. So instead, we're doing this piece, and so we need a box so that we can expand out the x minus 4 and the x minus 4. So we have x squared as a result from x times x, negative 4x for that multiplication, negative 4x for that one, and then positive 16. Combining that diagonal to negative 8 means that you have x squared minus 8x plus 16. Alright, continuing on, this one is a binomial and a trinomial, so that just means that when we make our box, we're going to need it to be a 2 by 3 when we construct it. So we have x and minus 5 here for the binomial, and then the trinomial is x squared, 4x, and negative 6. So just a little bit bigger, but it's going to be the same thing. X to the first power and x to the squared means that we have x to the 1 plus 2, which is 3. Over here we're going to have 4, but then an x to the 1 and an x to the 1, so they add to be 2. Negative 6x for the next one. Negative 5x squared. Negative 20 from 5 and 4, but then the x is added on, and then a positive 30. Once again, your diagonals tend to combine together, and so we start with our answer of x cubed, but then we're going to have negative 1x squared from that first diagonal, negative 26x, and then 30. Alright, the last one here of this type, notice it's saying to the third. And so again, we cannot just distribute that 3. It just means that we're actually going to do a box to take care of x plus 3 squared. And then we're going to get that result and multiply it by x plus 3 one last time. So we're going to do 2 area models here. So the one is x plus 3 and x plus 3 again to get x squared, 3x, 3x, and 9. And so that result, with the diagonals coming together, makes x squared plus 6x plus 9. Now we're going to make a second box that's a 2 by 3. Because now we're saying that this actually became x squared plus 6x plus 9 that I now need to multiply still by x plus 3. So we have x squared for that column, 6x and 9, and then x plus 3 for this side. So our result is going to be x cubed from a 1 and a 2, x squared from the 1 and the 1 added, and 9x, 3x squared, 3 and 6 makes 18x, and then 27. So our final, after cubing something, means that we'll combine these diagonals once again, and we'll end with an x cubed plus 9x squareds plus 27x's plus a 27. So we end up having to do 2 of those area models. Alright. So this one here is actually very common in standardized testing and placement testing, that kind of thing. Basically, it's getting you to understand word problems, but then also the fact that a polynomial exists within it. So the length of a rectangle is 4 meters shorter than its width. So we're going to write a polynomial that represents the area of this rectangle. So going back to chapter 1 pretty much, the length of a rectangle, usually they give that as an L, is it equals 4 meters shorter, meaning there's going to be subtracting of a 4, shorter than, so remember that that's backwards, its width, which we call W. So writing that out, that means the length is the width minus 4. Then it says you need to write something that represents the area of a rectangle. Well, area, if you know of a rectangle, is the length times the width. So what we're going to do is we are going to take this length and multiply it by the width. So how do we get length times width? Well, length is actually W minus 4. So W minus 4 times W, because width was W minus 4. Alright, so that means that we're going to distribute this W, even though it's on the back end of it, it's still multiplying in. So W to the first power times W to the first power adds 1 and 1 to make 2, and then negative 4 times the W just puts them right next to each other. So we have decided that the area is W squared minus 4W when you're talking about the width of it. Alright, so that is our multiplying polynomials. So most of it is using that box idea, but also then talking about distribution, and then also understanding that when you are multiplying powers with the same base, you just add those exponents.